Hello, you are welcome to our science class today. Today we are continuing in our lesson. We will be having today part 4 of the science lesson. We are still on Unit 2, Module 1, and Dynamic Earth, taking Lesson 1 from that module. Quickly we go to the objective of today's lesson. In our lesson today, we want to analyze Alfred Wegener's continental drift hypothesis. We've talked about the continental drift hypothesis. We want to analyze what did Alfred, the great German scientist, what are the things he spoke about, what are the things he looked at in this continental drift hypothesis. In part 3 of our lesson, the lesson before this one, we looked at the evidences that supports the continental drift hypothesis. In part 1, we started all the way from part 1, where we looked at how we identify that actually the surface of the earth is constantly moving. And we went ahead to lesson 2, the part 2 of this lesson, when we looked at the evidences. And lastly, we looked at part 3, where we compared the South American continent and the African continent, looking at the matching coastlines of these two plates, which are also part of the evidence that the continents, the tectonic plates are drifting apart, as was proposed by the great scientist Alfred Wegener. So today we want to look at his hypothesis to analyze and to find out what happened, what are the things he said, how was it accepted or was it not accepted. So, like we always do, we have to watch a short video, and in the video, as you watch, you have to quickly make connection with the video and alongside with what we are learning today.
Alfred Wegener proposed a theory in 1912 that the great continents of the Earth had drifted over geological time and were once all joined together in a giant land mass we now call Pangaea. His idea was based on the way the present continents fit neatly together, and by the way bands of fossil-bearing rocks join up across continents like this. Unfortunately, Wegener was unable to provide a mechanism for this movement, and his theory was ridiculed by the scientific community until 1965, when the theory of plate tectonics was published. This proposed that the continents were moved around on great plates driven by convection currents in the hot mantle of the Earth. For details, see our related video. Perhaps the most dramatic evidence came from the magnetism of rocks each side of the mid-ocean ridges. When rocks solidify, they become weakly magnetic in the direction of the Earth's magnetic field. However, every few million years, the Earth's magnetic field flips, so the north magnetic pole becomes south pole, and vice versa. And this change is signaled in the rocks. Scientists found that the rocks each side of the mid-ocean ridge were magnetized first in one direction and then in another, like this. Magma solidifies, locking in the magnetism. New magma forms as the plates move apart. The magnetic field reverses. More magma solidifies, locking in the reversed polarity, and so on, creating a pattern that repeats each side of the ridge, with the rocks getting older the further you are from the ridge. Clear evidence of the ocean moving apart over millions of years. Further evidence came from plotting where Earth's volcanoes and earthquakes were situated. From this map you can see that they form lines around the globe, marking out the edges of the great tectonic plates. You get almost all earthquakes and volcanoes at plate boundaries. And finally, we find the great mountain ranges right alongside where two plates are pushing into each other. The Himalaya are being thrust upwards as India moved and is still moving slowly into Asia. And as the Pacific plate is subducted under the Asian plate, the islands of Japan, with many earthquakes and volcanoes, and the deep ocean trench to the east, were formed and are still being formed.
Okay, so you see, from the video we watched, we can see the Alfred Wegener's continental drift hypothesis. In this hypothesis, he mentioned two main points. He talked about the Pangaea, when all the continents are combined as a supercontinent, and he talked about the matching coastlines, and also he talked about the matching fossils, like we saw when we were talking about the evidences. These were the two main points that Alfred talked about. But we see that he didn't have more evidences to support his claim. He couldn't explain how this movement is going until after many years that the scientists came up with the plate tectonic theories, and they were able to explain actually that within the oceanic plates and the continental plates, that there is a movement going on over the millions of years that went by. So with this, they were able to agree with the theory of Alfred and went ahead to build more facts and evidences connecting to the continental drift hypothesis. So this is what we have here. Continental drift theory, we talked about this in part 2 of our lesson. Now we can see that the work that Alfred did right there in 1912 came to be accepted by great scientists after many years, having seen that really the continents are drifting right from the first, when it was like a supercontinent, and to the present state now, when it's all drifted slightly apart from each other. Now, let's look at Alfred's work. Remember our objective? We want to analyze what Alfred Wegener did in his hypothesis. Quickly, we look at it here. He is a German scientist, or he was a German scientist who suggested that the continents have and are moving. That is his theory. We call it continental drift hypothesis, continental drift theory, or the theory of continental drift. This was done by the man called Alfred Wegener. Now, in his theory, in his hypothesis, like I said before, he was mentioning 2 points. Number one, that the earth the continents of the earth were once joined as a single landmass, which we call Pangaea. And also he said that the Pangaea began to slowly move away from each other. The continent began to slowly move away from each other due to the instability of the magma underneath the surface of the earth. Like I said before, he gave these 2 points, but he didn't have good evidences to prove how it's happening, how the continents are drifting apart. Now quickly, you go to the book. In your book, in page number 11, you are going to see the continental drift. We have it there, and you will see this page. Please quickly open to this page, page number 11, because we are going to be looking at it critically to analyze Alfred's hypothesis. Now quickly, we watch the short video we have here. I hope it will play quickly with, okay, I think it's coming.
Wegener was forced to the astonishing conclusion all the dry land on the planet once upon a single landmass.
So we see from what we have in the video, just like what we saw before, the idea of Alfred, the continental drift, when he studied and he said that the earth was once one supercontinent. Now we go to the question we have in that page. Always you have to know, when we have a question in any of the pages in the book, we are supposed to write down the answers by ourselves. Okay, now the first question is asking, what was Pangaea? What was Pangaea? All the way from part 1 of this lesson, I've talked about it again and again. So please try to remember and to write it. What was Pangaea? Now we go to question number 2. It's asking us, describe Wegener's continental drift hypothesis. How can you describe what Alfred Wegener said in his hypothesis? That's question number 2. Now, question number 3 is asking us here that the most obvious evidence that continents move on Earth's surface is that the continents appear to fit together like giant pieces of a puzzle. We saw this in part 2 of the lesson when we talked about the evidences. Now, but scientists were skeptical and Wegener needed additional evidence to help support his hypothesis. If you had discovered continental drift, how would you have tested your hypothesis? That's a question. Use the space below to jot down ideas of the evidence you would collect and clues you would search for. Now, in this number 3, I would like you to, if you are to talk about the hypothesis from what Alfred did, what are the points, the clues, the ideas you're going to be looking for to find out about these continental drift hypothesis? So that's the page we have in page number 11. I'll give you 2 minutes to see if you can get the answers. Question number 1, question number 2, and question number 3. Very quickly. Please try to do that by yourself. Okay, because of our time, quickly we go to the PowerPoint again. Here I've tried to make a summary of the answers for question 1 and 2, but question number 3, I would like you to provide the answer by yourself. So here in question number 1, it was asking us, what is Pangaea? I wrote, Pangaea was a supercontinent composed of all the continents on the Earth. This is the answer for question number 1, the summary answer for question number 1. Pangaea was a supercontinent composed of all the continents on the Earth. Question number 2 is asking, describe Wegener's continental drift hypothesis. Now we have here, continental drift hypothesis suggests that over millions of years, Pangaea split up and the continent drifted over Earth's surface. This is what the hypothesis is telling us about, that over millions of years ago, it was all in one called supercontinent. Then as the years go by, slowly, the continents begin to drift apart to what we have today. Now, as you can see on the screen, I wrote number 3, you have to do it by yourself. Try to do it by yourself. So before we finish the lesson today, let's try to take the plenary again. Another name for Pangaea is what? Try to find the answer. You have to always use the plenary to assess your understanding from the lesson. The second question is asking you, summarize Alfred's continental drift hypothesis in one sentence. If you're to tell someone about what Alfred said in his hypothesis, what will you say? Try to find it there. He talked about the supercontinent. He talked about the drifting apart of all the continents. And here also I have some few questions that you might want to attempt. Try to attempt them to be sure that you understood. In lesson number 2, I think I explained the meaning of hypothesis. Continents, you know that. What Wegener named his supercontinent what? All of these questions are very easy. Try to attend to them as much as you can. So quickly before we finish, so now we've already analyzed, we are able to analyze Alfred Wegener's continental drift hypothesis. We talked about 2 points. He said about the supercontinent, and he said about the drifting away of these continents. So for him, it was like the continent is like a great puzzle that can fit together, and also he said they began to drift apart. Thank you so much, and see you in the next lesson.